So let me, yeah, okay, fine, one more. And then what I do is, okay, for all z, so why not just use eta, let's say j. So let me expand this out a little bit. This is a0 eta j, right, plus a1 ai eta j plus 1/2 a I, man, okay. Fine, at some point or another I'm going to have to start numbering these stupid indices. I1, I2, eta I1, eta I2, eta j, right? And so forth.
I just have a quick question.
Sure.
On the first line, is it for all z, or is it for all a?
For all z.
Or are we trying to show z is equal to 0?
Curses. That's supposed to be a. Oh, but
I think that's right.
I'm trying to show a equals 0. Oh, this is what's wrong.
Yeah. Oh. Are we trying to show the second one's equal to 0? Like on the line above that? I thought we were replacing like z minus w with the cursive z.
Oh man, yeah, I'm sorry. You can. Oh, stink! You're right. Man, that's gonna matter. Oh, costs me more writing over here.
Sorry.
It's okay. Okay, it's not that much writing. I can deal. Okay, so then you just start thinking about it, order by order, right? We get that. Now you have to think more. You have to be careful, right? The only way that I get information about a particular coefficient is if the product of the Grassmann generators next to it is not 0. If there's a repeated Grassmann generator, we're out of luck, right? So this immediately tells me that z naught is equal to 0, right? And so for zi, right? This will not give me I get that z. I also get that zi is equal to 0 for I not equal to j, right? Fix j for a second here, okay? So I get I is equal to 0 for I not equal to j. When I is equal to j, then this is 0, and I have good information about z sub j, right? If this is confusing, you could start by doing a to 1, then do a to 2, then do a to 3, then do a to 4, and go like that. But then over here, I will also get that, you know, z I1, I2 is equal to 0 for all, you know, I1, I2 not having j. I mean, there's a better way of denoting that, but there can't be a j index in there, right? Mm. Okay. Then what you do
for each one. Then
you just do for j plus 1 or something, right? I mean, if to be more explicit, if you do j, suppose we're doing j equals to 1, so you don't get information about z1. So you just multiply by a to 2, right? And when you do that, then you get information that z1 is 0 in the next step. And so whatever you miss in the one multiplication, you can multiply by a different generator to pick up information about that in the next multiplication. And if you choose the right notation for this argument, you can actually be pretty convincing. I don't know if I've made you, I don't know if I've convinced you guys it's true or not, but it's my attempt. I said it's worthwhile to pause and see why this proof fails in the finite case. All right. For example, so I actually have an example in the finite case. You can have see here. Yeah, like if you had doubly generated supernumbers, just 2 generators. Check this out. If you had A times 3, A to 1, A to 2, that's the top form. Then that would be equal to A times 4, A to 1, A to 2, for all A. This is the N.
Right.
Because it's automatically 0. You can't detect any information about the top form multiplying by degree 1, by the generators themselves. This proposition I'm about to write is useful in this is a technical one, which I will prove, but it's interesting how it gets used. Property, if Z is a supernumber, if the body is 0, then for each that must be, I think I'm missing a norm here. The supernumbers are not any more ordered than the complex numbers. Okay, yeah. I wonder if I made that past my thesis committee. There exists, I don't know. There exists, they're good people. They're good thing past me. Alpha greater than or equal to 0, such that, I don't know why I make these videos. Take away my degree. Let's see here. A to the N less than or equal to alpha times eta to the N power. Oh, maybe that is. Oh, that is a real number. Sorry. That is a real number.
Should we use something besides eta?
Yeah, exactly. 8 is a bad choice for my notation, isn't it? So let's use upsilon.
Heck.
7.
I refuse.
It works so well in this case.
It really
0
does.
less than 7 less than 1.
No. So if Z is a supernumber, a bodiless supernumber, so it only has a soul, and you have a real number between 0 and 1, there exists some alpha greater than or equal to 0 such that the norm of the... Where is A? What's this A?
Are you sure it's not a Z? Or...
That's gotta be Z. That's gotta be Z. I think it's a typo. Sorry about that. Otherwise this isn't interesting. Yeah.
I start doing my math on some pen.
Should have done that long ago, Jeff.
I know. You'll be able to run by now.
Alright, so let me just do, if I still have time. It's debatable, but let me do at least one interesting calculation before we're done. So, anyway, you got these supernumbers, right? And they have basically the same properties as complex numbers. Just the rub is that you've got commuting and anti-commuting ones, and if you want to get into the substructure, you have to study the Grassmann generators, basically. Long story short, you can think about variables, which are supernumber valued, in the same way that you think about real variables, right? So, for example, what I usually think about is like if I've got Z, I can rewrite it as, say, x plus theta. now this x, where, you know, x is an element of the even ones. I don't know how to write that evenly generated. I don't have another good notation for it at the moment. And theta is an element of the oddly generated ones. Oh, down here. So this would be like x, and this would be like theta. All right? So, fun stuff. Z squared, what is it equal to?
This is the trick.
Hmm?
Wait, this is the trick.
So you got yourself x squared
Plus 2x theta
plus theta x plus x theta plus theta squared. Theta squared.
Oh, yeah, never mind. They
Theta
don't-
squared is
they
0
don't-
though, because the odd numbers anti-commute with themselves.
Yeah.
Which I probably should, well, I will not prove that. To prove it, you could do an explicit calculation with Grassmann generators.
Wait, wouldn't the even part also be 0?
No. These even numbers commute with everything else.
No,
Basically,
no, I mean the first part, like the x squared.
no, because, for example, yes, I used to think that. But then you think about this. Yes, these square to 0, but there's also the eta 1, eta 2, eta 3, eta 4 term. And also the eta 3, eta 4, eta 1, eta 2 term, which leads you to 2, eta 1, eta 2, eta 3, eta 4. As you can see, the square of this even supernumber is not 0. Yes, the traditional square terms go away in terms of like the Grassmann generator being repeated, but there's still all kinds of cross terms which do not vanish,
Okay.
generally speaking.
Okay.
There are certain even supernumbers which square to 0, that's true.
Okay.
That is true.
For example, just
Sorry.
eta 1, eta 2.
Exactly, eta 1, eta 2 would square to 0. But also keep in mind here, x is not a particular supernumber, it is a variable. It is a notation for possible even supernumbers, right? Just like x is a real variable. Okay, so if you have two variables, like theta plus beta, they're both odd super number valued variables, and you square that, what do you get?
So it's going to be 0.
No, yeah, this is 0, right? And then, finally, my last calculation for the day. What happens if you take the exponential
So,
of a super variable, of a mixed one, like x e to the x plus theta? What's that look like? I'll do the easy one first. What's e to the theta? 1 plus theta plus 1/2 theta squared.
0. Yeah, so it's just 1 plus theta.
Yeah, it's 1 plus theta, right? E to the x would be what it usually is. If you do e to the x plus theta, that would be 1 plus x plus theta, right? Plus 1/2 x plus theta squared plus dot dot dot, which is 1 plus x plus 1/2 x squared plus dot 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 dot, then plus what? What remains? I mean, you got a plus theta, right? This one gives you a what?
X squared plus x theta plus theta x.
Alright, I got the x squared over here.
Right, so it'd be 1/2 theta squared, which would be 0.
Well,
I mean,
but there's also the x theta term,
right,
which is
yeah,
what?
so
Like
it'd be-
2 of those, right?
Right.
So it's just x theta. Anyway, when you keep doing this, what you'll get is it's same as e to the x times e to the theta, where that's... I'm kind of in a hurry right now, so I can't prove it for you, but pretty sure that's what happens. So you'll be able to, if you keep foiling it out, you'll be able to collect these x theta terms, and you'll end up generating higher and higher orders of x. And like that's, there's the 1. So these two terms are the first term in this. It's theta times 1. Here's the x times theta term, and it keeps happening at higher orders. So that's what the exponential of a basic supervariable looks like. It's kind of boring in the fermionic variable.
Oh, that was it. You didn't put any exponentials in the linear test either. That was sad.
Oh man.
That was sad.
Friday.
Ah. Friday.
So you are planning on giving us work Friday.
What shall I do Friday? I still have to cover linear programming though. I missed a department meeting once, and linear programming got put in linear algebra somehow. Man, that was a bad meeting to miss. 'Cause that was not something I would have. Definitely, I would have fought that.
Yeah.
They did it because you were alive.
Alright.
Yeah, we're done.